Okay, I think we are on. So today we will be giving code forces round 18, 881 div 3. Okay, so let's begin. Sasha has found an array of n integers and asked you to paint elements. You have to paint each element of the array. You can use as many colors as you want, but each element should be painted into exactly one color. Each color there should be at least one element of that color. Because max of s minimum s is the sequence of elements of that color. The cost of the whole coloring is the sum of costs over all the coloring. Maximum possible cost of the coloring. So we have like use as many colors as you want, but for each color should be painted into exactly one color. The cost of one coloring maximum of elements of that color to the whole coloring is the sum of cost over all the colors. Well, this you painted its element into two colors as follows. I have color one, then the cost of color one is max of itna is itna. So 154 minus min of 154, then this. Okay. Okay, 6 max of s is 1, then 5 minus 3. Maximum possible cost of the coloring. Okay, so the maximum possible cost will be, we will like put uh, two elements in one set. So that will be the best way. And we will put minus in the smallest number and plus in the largest number. Okay, so this is 12 and then 39. Okay, so then what we want to do is x is equals to first dot a dot begin comma a dot end if I is less than x. X is equals to 1 by 2 plus 1 by 2. Okay. If I is greater than equal to y, we out equation. 7 0 11 23 0 5. Nice. I think this should have been clear because that will be the maximum sum. If we divide the it all in the groups of two and we will take one from lower half and one from middle half in each group, then that will be the best sum. Okay, nice. Hmm. Today, Alex brought an array A1, A2, A1 of length n. He can apply as many operations as he wants, including zero operations, to change the array. In one operation, Alex can choose L and R and multiply all the elements of the array to R inclusive by minus 1. Choose any L and R. In other words, Alex can vary by in one operation. For example, if n equals 5 array 1 minus 2 0 3 minus 1 3 is equals to 4 becomes 1 2 0 minus 3 minus 1. This is late for school, so you should help him Maximum possible sum of the numbers in the array, which can be obtained by making any number as well as the minimum number of operations that must be done for this. Okay. Okay. One, two, three. Three operations and 27. Ah, okay, so I will not take zeros because zero will be like fault faulty numbers. Okay. So then B dot. So when I will be creating my array, I will just ignore all the zeros that I'm getting. Here, here in B. Okay. So this way, I will not have to care about zeros anyways. So in answer is equals to zero, and count is equals to zero. Units. First of all, best sum will be when all the numbers are positive. So answer plus, okay, here this is equals to x values of x is not equal to zero. G dot empty or x is less than zero, and then dot empty or b dot stack is greater than zero. Count plus if x is not equal to zero, I can see out answer count this one. Okay, so this should be if the zeros were not present, this is pretty simple. All the clusters of negative are the count and the absolute values, sum of absolute values is my sum. So we just want to avoid zeros anyways. So we will just don't take zero either. Okay. Damn, loading time is pretty bad. I guess we are doing this then. This should be accepted. I don't know why I'm checking it, but okay, see. Oh, tree. Oh, one day he was solving. Okay, as I said, one day he was solving another math problem. He came up with the interesting tree. The tree initially the tree only has one vertex with the number one, the root of the tree. Then Vanya adds two children to it, assigning them consecutive numbers two and three. And then he will add children to the vertices in the increasing order. Okay, one, two, three, four, five. We'll have infinite tree with root where each vertex will have exactly two children and vertex will be by layers. Vanya wondered what the sum of vertex numbers on the path from vertex with number 1 to the vertex with number n in such a tree is equal to. Counting asks you to help. Oh, well, if we see here, then we can easily observe that n by floor of n by 2 is the parent. So I just have to go from n to the parent. Okay. That's why this has more permission than the last problem. This is obviously more easier. Well, of course, if someone is like for newbies, that will be the difference, but for everyone above newbie, I don't think there will be any difference. is greater than 0. That plus is equal to m minus the expression. Okay, let's see. I don't see any problem. 4, 18, 71.26. Let's see, is there any problem? But it is 10 power 16, right? Oh, the sum will be at most 2n because n plus n by 2 plus n by 4. Yeah. So we don't have to worry about anything like that. What the fuck is damn, bro. So sum will be at most 2n. They could have given 10 power 18 just to confuse people. Timothy has an apple tree. There's no submission on last problem. That means that is like good enough hard because there are many people that do from the last. Timothy has an apple tree growing in his garden. It is rooted tree of n vertices and root of vertex 1. In the vertex 1, the tree is very unusual. It grows with its root upwards. However, it's quite normal for programmers trees. The apple tree is quite young, so only two apples will grow on it. Apples will grow in certain vertices. These vertices may be the same. After the apples grow, we start shaking the apple tree until the apple falls. Each time someone shakes the tree, the following happens. If a vertex U has a child, the apple moves to it. If there are several such vertices, the apple can move to any of them but falls from the tree. It can be shown that after a finite, both apple will fall from the tree. Timothy has Q assumptions in which vertices apples can grow. He assumes that apple can grow in vertices x and y. Wants to know the number of pairs of vertices a, comma b which apple can fall. Pair of vertices from which apple can fall from the tree. Where a the vertex from which the apple takes x fall, b fall. And do this. Okay. Maybe the same. After the apple grows, the apple falls. Falls fall. Each night on the tree, the vertex you has a child. Apple moves it. There are such vertices. The apple can move any of them. So my question is like, is there any dependencies? If I move this way, then my parent will also move this way. Like if two apples are on the same root. Okay, so this one shows that. Let's just see. 1, 5. The man, they couldn't have given a better test case than this. 1, 1. This one is better. Okay, so this is 4. Okay, so the apples are independent. They any one of can go anywhere. Dot cpp. Dot cpp. Test case. Yes, very much. Listen to them. And you, I listen. Yes. Listen to you, I listen. This one. Okay, so we just need to do DSS and the indication is you, you, I, size is equals to 1. Low size is equals to 1. N Q screen 1Q. Let's take the 0 and let's put less than the Q. Plus around Y beyond below X times Y. Oh, calculate. I didn't declare the vector below. Vector below. So this vector just contains the number of leaves below me. So 2, 2, 1, 4, 4, 1, 2, which is good enough, I guess. Let's just check on this one as well. They gave two test cases for a V1. 1, 2, 1, 4, 2. Okay. 4 seconds. Damn. Yeah, so this will pass most likely. So, okay. 180. F1 and F2 both have like zero submissions right now. Crazy. You are given an array of consisting of n zeros. You are also given a set of m non-necessarily different segments. Each segment is defined by two numbers, Li and Ri. Subarray. Ali plus 1 to Ari. Let's call the segment Li to Ri beautiful if the beautiful if the number of buses in the segment is strictly eternal. For example, here. You also have few changes. Since you are given the number x, which means that you must assign an element ax the value 1. Means that you must assign an element ax with the value 1. You have to find the first change after which at least one of given segments or report that none of them beautiful after processing all q changes. Okay, okay. Yeah. After two lines, okay. The number of which one of the segments will be beautiful or minus. Okay, so it's strictly greater than. Okay. So after n by 2 plus 1 operations, the complete range will be beautiful. That's for sure. So myself, none of the segments will be beautiful. Oh, oh, nice, nice, nice. So one of my ideas is that I will check is one of my segments good after like some binary number of changes, suppose 2 की power k. Then I can just do this all the time in big of n plus q times log for that binary change because for that binary number will be log of q. Okay, so let's just continue. And okay, so this should be possible doable easily when we got CPP. Okay, so let's just say that like at max the bit range will be 20. So I will be saying that okay, I will count the highest bit after which the answer is not possible, and then my answer will be that value plus one. Okay, the problem is insane by the way. Thank you. Yeah, thank you. And they are given L comma R, and they will given X. So N and M of the array number of segments. I guess W W. So, and can I even do binary search? Okay, I can just do binary search. Low is equals to 0, high is equals to M plus 1, high, high minus low greater than 0, greater than mid is equals to check of med. High is equals to med, high is equals to med, 3 also. High, okay, we have to put minus, we can put minus 1 too. This is pretty nice. If high is greater than M, minus 1, high, less than. Okay. That is it. And first M lines, then Q lines. Okay. 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 What it says, ranges RI. Okay, so 2, 4, Q. Okay. Q is later. I was actually afraid that Q, 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 Q9, in range of L, let's just do that, and we are all set. We have taken every input, and here we just do and here I have b of n plus 1 for I less than mid I plus b of n q of phi b of let's just say or prefix prefix of b of I plus plus 1 I less than equal to n I plus plus if prefix of I plus is equal to prefix of I minus 1 and L comma R R range if two times of R minus prefix of L is greater than R minus L return 3 return 4. Okay, so this should be enough. We are just finally searching on the query that gives me the answer. 3 minus 1 triple three one. If when there are like so many coincidences, like this just feels wrong somehow. Like so many threes as answer. Not sure it might FST or not, but okay. So we have an idea about binary search. This is just directly binary searching on the query from which you can get, and this will be like log queries. N plus m into log queries. N plus m into plus q. Like, maybe. Big O of n and m is less than n, so we can just say n whatever. Let's just see now. Oh, f has like way too many symbols. The only difference is u is equals to 1. R is abundant, like I now I know why there are so less ambitions. Just looking at this flawless statement, it feels like I'm just going to die. As is known, ohms is the capital of the burden node, not known. Like any capital, ohms has well-developed metro system. Ohm's metro consists of certain number of stations connected by tunnels, and between any two stations, there is exactly one path that passes through each of the tunnels, no more than once. There's exactly one path that passes through the stations. There's exactly one road is a tree. Okay. To develop the metro and the truck resistance, the follow system is ohms. Each station has its own weight. X belongs to minus 1. The station has a weight of minus 1. Then when the station is visited by ohms resident, a fee of 1 bird is charged. If the weight of the station is 1, rewarded with 1 bird. It currently has only one station with number 1 and weight x is equals to 1. A new station with weight x is added to the station with number vi, assigned a number that is 1 greater than the number existing stations. So listen, ohms wonders if there is a subsegment, possibly empty, path between vertex 2 and vertex such that by traveling along it, mhm, with exactly k balls can be earned. K less than 0. This means that k balls will have to be spent on travels. If Alex is interested in whether there is such a subsegment of the path, the width of the vertex. Mm, Alex, your question. Okay. So plus symbol without xi. With number a is and then three numbers here v k. This is the number here vi exists. This is a segment of the empty on the path between vi and vi. Hmm. Would be the same. Okay. 1 to 1 to 2. No. 1 to 2 to 1. Yes. +1 comma -1. Plus the 2. And then this is 1 to 2, which is 1, which is -1. Then 3, 1. S is either of length S+2, S+4, S, like this. This seems a bit more like, okay, now I know why. This is a bit more hard, even for u is equals to 1 case here. This is hard. Okay, we have like +1 here and -1 here. For 1 to 1 with cost not possible. 1 to 2 with cost 1. There is 1 to 1 it himself. Okay. If it was subsequence, this should have been a bit more easier. But this is subsegment. Okay. 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 Hmm. Flattening the tree might work, but that's not the end goal. Yeah, this F1 is legit really hard. Ah, we'll have to think a lot more on this. Okay. Okay. So instead of this, I'm saying that I have a sum. I want a sum capital S in the middle. Okay, small s in the middle. I have currently some capital S. Then I will remove some. x from here and some y from here. And then I will check whether I have that value from x from here. Okay. Then I know the value of x plus y. Uh, 1, 2, 3, and minus 1. Well, 1, 2, 1, and 1. Yes, 1, 2, 3, and 2. No. Why is this not? No. 2, 3, 2, minus 1. Why is this no? This subsegment possibly empty. Path between u and vi with the sum of bits exactly equal to ki. What? Isn't this? Isn't three? Okay, we added one here instead of two. I'm done. I thought we added minus one. That. And minus one. I have like some values here. Here. I have added minus three, minus plus one. Oh, okay. So in this case, this is so beautiful right here. So I can always maintain small l and capital R. I can create every value possible in this range, small l and capital R. And we can use this same technique over segmentary. I don't, I don't want to just, I don't want to do this with the like your classic heavy light decomposition. But F1 is really possible without that because I can just maintain the node that I will be taking. Okay, it's so fun. It's just, it's just so amazing. So I will maintain three values on this node, which will be my last ancestor, Do I even need to maintain this? I do. I do. Huh. I have a solution with heavy light decomposition for F2. But so my idea is that minimum Savarism and max Savarism in range L2R is what we need. But like merging them in that aspect will be really hard. Wait a minute. Ah, fuck. Just this is just so amazing. I can just do that directly using segmentary. I don't even need to like just okay. Such a such a job, boy. Define all a boolean comma a dot and a equal to CA. Yeah, that's why I printed all a because I'm using all a here somewhere, I believe. Or no, I'm not using all a here. Somewhere. So I think this gives me. Oh, I have not built factory properly yet. And some uh, min left, min suffix, min suffix, left suffix, left suffix. Sum is equals to like suffix is equals to min suffix, is equals to like, oh, now just need to merge them. Pretty nice, right? Fuck man, fuck this shit. Like now I don't even want to do this somehow. This is such a pain. think I will have to use binary lifting here. Binary lifting is just the better alternative in this case. Okay. Binary lifting is better because like I can go from for some place uh for some place like here to my parents, just children through which I came here. And I can get all of the benefits. So, damn. I got A dot I plus B dot I plus minimum of A dot E B minimum B. Ah, this is such a bad segmentary. I could have just made two segmentaries instead of one. One and just reversed the positions to get a better segmentary. Or should I do that? That will be a that will be such a Jod thing to do. Such a command. So this will reduce so much of my writing that half of which I have used already done. Perfect answer. Okay. And dot fifth, fifth. So minimum of a dot answer. Okay. B dot answer. No. A, a dot suffix plus B dot prefix. This is temp dot answer. A dot suffix is equal to, and this is I'm building max, right? Okay, I'm building max. Max of A dot sum plus B dot suffix and I dot suffix. And max of A dot suffix plus B dot sum suffix. All we are always merging right, left to right. Okay. Oh, I think this should be enough. Think there is no test case. Oh, there is test case. I wish my segment reworks in a first try. And CNN, let it be M, energy question one, F, excellent, adjacent, F, very, three, very, very distant, adjacent of either. It's easy, that's easy, that's easy. Well, okay. So far, so good. Yeah, and two, enough, and, 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 okay, so I have spec, Java, Yeah. Okay, so if D of U is greater than V, here V can V, and this is unless dot LC of I to this. Very good. This will allow me. Yes, because definitely. Not a good. Okay. Hello, nice. It at least function works like this. Okay. I was about to just mess up a big time and get really later. So, in let's do this show that potential of you come out. Left is equals to dot query in of ancestry, comma in of zero. That right is equals to is- I think I will have to invert the values in suffix to get a better answer. Damn, this problem just keeps getting interesting. Hmm. The right is equals to query of left dot here and system of b comma d of b minus d of a. Okay. B, 0, b of b minus 1, b minus and system. Not good. Left dot left dot left dot merge merge comma right, because in this suffix was actually the prefix. So when I got this as my node, I got this as my suffix, this as my prefix. But if I merge this to that, then I have to invert one of them. Left, right, or just return merge dot on. Does it work? Okay, at least it works. See out case greater than equal to low or case 35. Yes, no, that is. Okay, I have also here 1 and 3 and 9. And these are high. You high was 0. Oh, damn, this is working for sample 1. Is this working for no fuck? Fuck no. Damn, this just had to go so bad. Yes, yes, yes. Okay, I know why this is not working. It's still not equal to you. Now this should work. Fuck, I can't get minimum sub array sum. Well, actually, it doesn't really matter, even if I do that or not. Okay, I will just. That warning is annoying me currently. I want to just remove that warning somehow. I added warnings in my codes because recently there was a pretty interesting thing that happened to me that led me to do it. Okay, so minus 2 comma 2, which should not be possible, first of all. So, well, I don't want to be that guy, but won't I don't have to make it so complicated, by the way. Here, lf.kr plus 10, because the next. Okay, no, that won't be. I'm so dumb. Okay, so this shows minus 2 comma 2 for 1 to 6. 2. So I will have to just do 1, 2, 3. This one minus 1, minus 1. Then everything from 3, 4, 1, 1, 1. Okay, I can get something in the middle. We should not be there. Ah, okay. Hmm. Okay, minimum before me. I can at least pass F1. So I got my idea where I'm wrong for this problem. Okay, so because we will go from here to here and then back there, which will be plus 1, then this will be equal to plus 1, 2, even though there will be 1 minus 1 here. But this will be enough to make this bad enough going here once. Fuck. I will have to do like I think parent comma int range instead of int parent. Let's just forget this. Mm, mm, mm. Okay, so I will just be prefix sum int sum. Now this will be so interesting. So, so I is equals to mm sum minus ls comma minus mm 0 comma 1 comma 0 comma 1 comma dfs of I comma. Right is equals to the range of rv minus 1. Or auto and view is distance of I Zero science two. Equals to may not you got first not I got first. Best answer before me range of I got. Typically, we got the access not range of got second. Are you okay? Now yes, now yes, no, yes, no. For this one, this code should be suffice. This code should suffice. I don't want to like some kind of do. Okay, this has 360 operations. Zero to zero first one identified at first. Hmm, I don't know. Let's just check this. Okay. I don't know what is the well. Command with the parent command and then I don't know what is wrong now, but this should not be wrong. Comma some. Oh wait. Ah, I don't even know what the fuck is going on now. This should be correct. Max Savarism or min Savarism, and my min Savarism is what we need. I don't know why I'm getting W. Might be some silly reason or something. Some minus MX. Max is MX. I have an idea on how to solve that, but hmm, this seems to be. I don't know what the fuck is this problem. U dot first change the 5 dot first change the 5 dot second. U dot second. I am thinking of subsegment as the a subarray between them. Mhm. One. Very interesting. Oh, it is not pushing down. I'm just dumb. Fuck me, dude. This should be AC now. Okay, so this will of course be giving AC now. Also, okay now. For F2, we can do another thing. That is something like a square root, square root type something. So what I will do is I will say okay. No way, dude. Fuck, man. If it is this, then damn. Such a nice idea I got right here. We will create a binary lifting table. Lifting. Bro, what a solution. Okay, we can use binary lifting. I was gonna use I was gonna overkill this problem. Now I like feel good that I'm not overkilling anything. Okay, so lifting will be that, and that. Will be that node 18. 18 seems good enough because 17 blah 18, 18 seems good enough. What is 2 to the power 18? 2 to the 20 by 4. Nah, seems good enough. I would actually just do this. I just like if I have just one turn, left of zero is enough to determine that. If I have two, one is zero and one. Okay. Left of I of zero is equals to dot add yes, well, dot add value of X. This is such a nice side. Like I appreciate this idea, by the way, of using binary lifting table to just calculate everything. If I use zero dot add value. Yeah, and zero I less than x for I plus and 1. Now this seems pretty interesting. I will do merge. Sorry, sorry, just to zero. Zero is so good it has no effect on either positive or negative. Maximum answer dot merge. Now the answer comma. Negative. Yeah. Okay, so this says I can't declare a node before there was not declared, and this is true. Did you mean absolute get value, not ignored as it ought to be? Okay. It was not merge. Okay. It was not answer dot merge. Merge answer. Zero. You comma zero. Not just left and right. Dot. Right. Good. Okay. This will be this. Let's see. Does this work? Test three. Test three. Test three. Runtime element. Test three. Like I don't. I'm not even in the mood to like do something about that. This will give me the advantage that I want. I don't have to do this thing. I just created some extra, one extra padding over my current answer just to get the answer correct. But okay, am I getting it more wrong now? Okay, it should not be u minus minus and v minus minus. And because I wrote debug, that it actually printed answer. I removed debug. Will it show like again runtime error? Please get AC. For God's sake. Okay, runtime error test run. Select customer location. Do okay. हम्म, आराम से हो जाएगा ये। And now I should do this here because just you expression. Mm, mm, now I would say, hey, not in here. I think some kind of like out of bound error might be happening. Bro. It's just oh, I'm not putting anything in output. I'm genius. Okay, let's see where I'm most doubtful. Um, Okay, here. Hmm, interesting. So here it is bad. What the fuck? Shut it again. Does this work? Okay, at least it worked here. Now just have to. So if this doesn't work, we'll end the stream. Whatever happens, because 5 minutes remaining and okay. Runtime. We from here spent 25 minutes to come here. Interesting. Okay, uh, I don't know, man. This should not be happening. Hmm. Hmm. This wait a minute. This. Let's see what happens. Uh, I don't think anything should happen. Runtime error test from test 3. Okay. Well, the answer is most likely correct, but I can't get rid of this runtime error. So sadly, many people did this problem. Mhm. Time to, I guess, stop recording.